Hello everyone and welcome to 30 days of DSA challenge where we will be solving a DSA problem every day for the next 30 days. So this is our day number 19 and today we are going to solve a problem based on heap and the level of this question is going to be medium. The name of this question is kth largest element in an array. You will get this question link in description and you can also download this Excel sheet from description. Now without wasting much time, let's see our question on LeetCode. So here we are on LeetCode and let's read our question. So the question says, given an integer array named as nums and an integer k, return the kth largest element in the array. So question is pretty simple and straightforward. Question says that I have given you a vector named as nums and one integer named as k. You have to return me the kth largest element present into our array, right? Note that it is the kth largest element in the sorted array, not the kth distinct element. Okay, so we do not have to do anything with the distinct elements, right? The question is not to find out the kth largest distinct element. It is just that you have given an array, you have to sort the array, and then you have to just return the kth largest element present in that sorted array. Okay, and here are some sample test cases. Here is also a follow-up question. Can you solve it without using sort or any sorting algorithm? So we will look into it how we can do that. So let's take some sample test cases to understand what is the question and how we can solve it. So let's take this example first. So this is our nums array, right? And this is the value of k, correct? So we have to find out the kth largest element present into our nums array. So what we'll do, we'll firstly perform a sorting, right? And after sorting our array, we have to return the second largest element, right? So from the back, you can clearly see that this 6 is nothing but my first largest element and this 5 is nothing but my second largest element. Due to this, the answer for this sample test case will be equal to 5, right? I hope it is clear to you. Let's take one more example. So let's say that this is our nums array and this is the value of k, right? So we have to find out the fourth largest element present into our nums array. So what we'll do, firstly we will perform sorting, right? And after sorting, this is our nums array and we have to return the fourth largest element, right? So from the back, you can see that this 6 is nothing but my first largest element, okay? This 5 is nothing but my second largest element, right? This 5, right, which is present at index number 6 is my third largest element. And this 4, which is present at index number 5 is my fourth largest element. So the answer for this particular sample test case will be equal to 4, right? Remember, in the question, it was clearly mentioned that we do not have to do with the distinct elements, right? We just need to return the kth largest element present into our sorted array. Okay, so I hope question is clear to you. So now let's think of how we can solve this problem. So the very first approach which can come to your mind is, firstly, let's perform one sorting algorithm. And after performing the sorting algorithm, we can return the kth element from the back, right? We can return the kth element from the back of our sorted array, right? And how we can do that? See, if I write the size of this nums array, so it is nothing equal to 6, right? And k is equal to 2. So if I just return nums of n minus k, this will be my answer, right? How it is? So see, what is the value of n? N is 6. What is the value of k? It is 2. If I do 6 minus 2, it comes equal to 4. And here in this array, you can see that at the fourth index, we have our answer equal to 5. Okay, let's take one more example. So here for this sample test case also, we will do the same thing. Firstly, we will perform the sorting, right? And after sorting our array, we have to return the fourth element from the back, right? How we can do that? Firstly, I need the size. So the size for this particular nums array will be equal to 9, right? And what is the value of k? Value of k is nothing but 4, right? So I just need to write 9 minus 4, or you can say n minus k, right? So it is 9 minus 4, it is equal to 5. So I just need to return nums of 5, right? And here in this sample test case, you can clearly see that at index number 5, we have 4, which is our answer. So now if we talk about the time and space complexity, then the time complexity for this particular approach will be equal to O of n log n, right? Where n is nothing but the size of our nums array, right? And why it is equal to n log n? Because we are performing sorting, right? we are sorting our nums array, due to which the time complexity will be equal to n log n, correct? And if we talk about the space complexity, then the space complexity will be equal to big O of 1, right? The space complexity will be constant. So this is our time and space complexity. I'm not writing the code or pseudocode for this particular approach because I think that it is pretty easy and you can do it by your own, right? But in the question, it was clearly mentioned that can we solve this problem without sorting, right? So now let's think of how we can solve this problem without using any sorting algorithm. So now let's think of how we can solve this particular problem without using any sorting algorithm, correct? So the name of this question is kth largest element. Whenever you see these type of keywords in the question, that is kth largest element or kth smallest element, you can start thinking of heap data structure, right? Now, what is a heap data structure? So it is a data structure which stores element in sorting order, right? In sorted order, right? And the sorted order can be of ascending order, correct? And the sorting can also be of descending order, right? And this also says that we have two types of heap, correct? We also have two types of heap. So if we talk about the ascending, right? If we talk about a heap data structure which stores element in ascending order, so it is known as min heap or minimum heap, you can say, correct? And if we talk about a heap data structure which stores element in descending order, then the name of that heap data structure is maximum or max heap, right? I hope it is clear to you. Now let's say that we have one array and the elements in the array are 5, 1, 4, 2 and 3, right? Now if I store the elements of this particular array into a minimum heap, right? So the sorting will be in ascending order, right? Let's say this is my minimum heap, right? This is my minimum heap, and if I store all these elements into my minimum heap, then it will be stored in ascending order, correct? So firstly I'll have 1, then I'll have 2, then I'll have 3, then I'll have 4, and then I will have 5, right? So at the top you can clearly see I have the minimum element, right? I have the minimum element. Similarly, if I store all these elements into a maximum heap or into a max heap, then elements will be stored into descending order, correct? So firstly I will have 5, then I'll have 4, then I'll have 3, then I will have 2, and then I will have 1, right? So at the top you can clearly see we will have the maximum element, right? So this is our heap data structure, and these are the two types of heap. First is the minimum heap and second is the maximum. So now let's think of how we can solve this problem using a heap data structure, right? So we have to return the kth largest element. So the first heap data structure which can come into our brain is max heap, right? Is max heap. Now why max heap? Because we have to return the kth maximum element, right? So let's try to solve this problem using a max heap, okay? So what I'll do, firstly I'll put all these elements into my max heap, right? Into my max heap, right? So after putting all these elements into my max heap will look like this, right? Firstly I'll have 6, then I will have 5, then I will have 4, then 3, then 2, and then 1, okay? So what do I need to return, right? I need to return the second largest element, right? I need to return the second largest element. So what I can do, I can just remove this 6, right? Because this is not my answer. This is the first largest element. This is the first largest element. I do not need 6. I need to return the second largest element. So what I'll do, I can just simply remove it from my heap, right? I can just remove it from my max heap, okay? Then what is 5? What is 5? This 5 is nothing but my second largest element, right? This 5 is my second largest element. So now what I can do, I can just simply return this 5, right? I can just simply return this 5, okay? So now let's say that the value of k is equal to 3, okay? Let's say the value of k is equal to 3, okay? And we have to find out the third largest element present into our nums array, right? We know that into our max heap, the element will be stored into descending order, right? So this 6 is nothing but my first largest element. This 5 is nothing but my second largest element. And this 4 is nothing but my third largest element, right? So what I'll do, I do not need 6. So I'll pop it out from my max heap, right? Then I have 5 here. I do not need 5 as well because I need the third largest element and this 5 is my second largest element, right? So what I'll do, I'll pop this 5 as well, right? And then I have this 4 and this 4 is my third largest element. So I will return this 4, right? I will return this 4, right? So I hope this particular approach is clear to you. It is pretty easy. Firstly, we need to store all our elements into our max heap data structure, correct? and then we have to remove some elements from the top depending upon the value of k, and then we can return our kth largest element. Okay, so let me just write pseudocode for you so that you will understand in more depth. Okay, so what do we need? Firstly, I need a max heap, right? So let's say we have a max heap named as max heap itself. Okay, and we have our nums array. So firstly, what I'll do, we will try to iterate into our nums array, and while iterating, what I'll do, I'll put all the elements into my max heap, right? So here I will write max heap dot push nums of I, right? I hope it is clear to you. Okay, so we have put it all the elements into our max heap. Okay, so after doing this, what do we need? We need to return the kth largest element. How we can do that? I can write while k is not equal to 1, right? While k is not equal to 1, just pop the element which is present at the top. Okay, so I'll write max heap dot pop. Okay, so this pop operation will automatically delete the element which is present at the top. Okay, it will automatically do this. So then we just need to write k minus minus, right? And after that we can just simply return max heap dot top. Okay, we can just do this directly. So now if you are wondering why I have returned this particular block of code, so let me just explain it to you. So let's say that let's take this particular example to understand. So let me just write all the elements back. So we had 6, then we had 5. Okay, now let's say the value of k is equal to 3. Okay, so what I have done, I have just written a code where while k is not equal to 1, right, I need to do a pop operation, and then I just need to decrement the value of k. Okay, I hope it is clear. So firstly my k is equal to 3, right, and this is my topmost element, right? This is my topmost element. So I will just check, is the value of k is equal to 1 or not, right? So right now the value of k is equal to 3, it is not equal to 1. So I will come into this while loop and I'll do a pop operation, right? It means I will delete the element which is present at the top, which is nothing but 6, correct? And now the value of k will be decremented. So now the value of k is equal to 2, and this 5 is my topmost element, correct? Again I will check, does the value of k is equal to 1 or not, right? So right now the value of k is equal to 2. So what I'll do, I'll again come back into my while loop, and then I'll again do a pop operation, right? So I will pop out this element, right? I will pop out this element. So now this element will be removed from my max heap, and now my top will be pointing here, right? After doing this pop operation, what I need to do is I need to decrement the value of k, right? So currently the value of k is equal to 2. So I will decrement it, and now it will become equal to 1. Correct? Again, I will check what is the value of k. Is it equal to 1 or not? So now you can clearly see that the value of k is equal to 1, right? The value of k is equal to 1. So if the value of k is equal to 1, then this while loop will not get executed, and then we will directly return the element which is present at the top, which is nothing but 4. And this 4 will be our answer in this particular sample test case. Okay, so I hope it is clear to you. So now let's talk about the time and space complexity. So if we talk about the time complexity, then here you can clearly see that we are running a for loop from I equal to 0 up to n, where n is nothing but the size of our nums array. So here the time complexity will be equal to O of n, right? But inside this for loop, what we are doing, we are pushing elements into our max heap, right? So you need to know that the push operation takes O of log n time complexity into our maximum heap or even into our minimum heap. Okay, due to this, the time complexity will be O of n log n. Okay, and the space complexity will be equal to O of n, because we are using a maximum heap, right? We are using a max heap data structure to store all our elements, right? Due to this will be our time and space complexities. But if we compare these time and space complexities to the previous solution in which we were using sorting, then in that particular solution, the space complexity was equal to O of 1, right? And the time complexity was same as O of n log n, right? So this particular solution is not better than our previous sorting solution, right? So we need to think of another solution which probably takes some lesser time complexity. Okay, so now let's try to solve this particular problem without using any sorting algorithm and without using maximum heap data structure. Okay, so here we have to return the kth largest element, right? So we have to return the third largest element for this particular test case. Okay, so let's say I have a box. This is my box, and in this particular box I will only store k number of elements, right? I will only store k number of elements, and here in this test case you can clearly see the value of k is equal to 3. So you can say that in this particular box I will store 3 elements. Okay, so what I'll do, I will put the initial 3 elements from my nums array into this box. Okay, so these are the initial 3 elements. I will put them into my box. So I will have 3, then I will have 2, then I will have 1. Okay, now after putting my k initial elements into my box, I will start my traversal from the kth index. Okay, so now you can say that this is my kth index, right? Because the value of k is equal to 3. So here I'll have a variable, let's say I, which is pointing to the kth index. Okay, now we will see what is the element present at this particular index. The element is nothing but 5, right? The element is nothing but 5. And what I have to do, I need the third most highest element present into this particular nums array, right? And in this particular box I have 1, 2 and 3, right? And in this box the minimum element is 1, right? In this box the minimum element is 1, right? And I got someone who is greater than my minimum element, right? The minimum element is 1 and I got 5, which is greater than my minimum element. So now I can say that I do not need this 1, right? Because this 1 will never be my answer, because I got someone who is greater than 1, right? So now what we'll do, we will remove this 1, right? We will remove this 1 from our box, and after removing it, what we will do, we will put 5, right? We will put 5 into our box after removing 1. Okay, and after doing this, again our I will move forward to the next index, and now my I is pointing at index number 4, and the element present at index number 4 is nothing but 6, right? So now what I'll do, I'll again see what is the minimum element present into my box. You can clearly see that the minimum element is 2, right? So I'll compare this 2 with the 6. This 2 is lesser than 6, right? This 2 is lesser than 6. So I got someone who is greater than 2, right? And I need the highest element, right? I need the third most highest element, right? So this 2 can never be my answer, right? This 2 can never be my answer. So what I'll do, I'll just remove it from my box, right? I will just remove it from my box. And after removing it, what I'll do, I will add 6, right? I will add 6 into my box. And after doing this, again, my I will move forward to the next index. So now my I is pointing at index number 5, right? And the element present at index number 5 is nothing but 4, right? The element present at index number 5 is 4. Okay, now what is the minimum element present into our box? You can clearly see that the minimum element is nothing but 3. So we will compare, is this 3 is lesser than 4? You can see that yes, it is lesser than 4. And since we need the kth largest element, we know that this 3 can never be my answer, right? This 3 can never be my answer. So what I'll do, I will just remove this 3 from my box and I will add 4, right? I will add 4. After doing this, again, my I will move forward to the next index. And now you can say that the I will go out of bound for this particular nums array. After doing this operation, in this box, we have 3 elements. And now I can say that these 3 elements are my k largest elements, right? These are my 3 most largest elements present into my nums array. What I need the third largest element, right? I need the third largest element. So you can here clearly see that the first largest element is this 6. The second largest element is this 5, and the third largest element is nothing but this 4. So what I'll do, I will again return 4. This 4 is nothing but the minimum element present into our box. So in this particular approach, what we have used, we used a box, right? We used a box, and in this particular box, we were taking the minimum element present in this particular box, and then we were comparing it to the current element in our traversal, right? And if the minimum element was lesser than my current element, then I just remove the minimum element and I add this nums into my box. Okay, so now we need to think about a data structure which can fulfill all our these conditions, right? What are our conditions? We need to find out the minimum element, correct? We need to compare it with the current element. If the minimum element is lesser than the current element, then I need to pop out the minimum element from my box. Okay, and if you know, then this particular box is nothing but our minimum heap. This is nothing but our minimum heap, and our minimum heap fulfill all our requirements for this particular approach, right? We need the minimum element, right? We need the minimum element. So we know that in top, right, at the top of our minimum heap, we have the minimum element, right? And we need to pop out our minimum element, right? So if I do a min heap dot pop, then the minimum element will get removed from my min heap. Okay, so I hope now you know that why do we need minimum heap. Okay, see, in other YouTube videos you will definitely find out that they say that we need to use minimum heap, right? But there are very less people who explains that why do we need minimum heap, what is the need, why we use this particular data structure, correct? So I hope all these things are clear to you, and now let's try to code this particular approach. So what was our first step? Our first step was to put the initial k elements into our box. Okay, so let's say that we have a minimum heap named as min heap. Okay, and we need to put the first k elements into my minimum heap or into my box. Okay, so what I'll do, I will just run a for loop where I'll have int I is equal to 0. It will run up to it is lesser than k. Then what I'll do, I will do min heap dot push nums of I, right? Nums of I. So from this particular for loop, what I am doing, I am putting the k initial elements into my minimum heap. Okay, after doing this, I need to do a traversal into my nums array from index k. Okay, so I will have int I equal to k up to k is lesser than n. Okay, so what do I need? I need to take the minimum element and then I need to compare it with my current element. Okay, so here I will have, let's say we have a variable named as int cur, which is just giving us the current element. Okay, then we will have the minimum element. So let's say I have int mini, which is nothing but min heap dot top. Okay, so now here I will write the condition that if my minimum element is lesser than my current element, if this is the case, now what I need to do, firstly I need to remove the element. Firstly I need to remove the minimum element, correct? So what I'll do, I'll write min heap dot pop. Okay, so the minimum element is now removed from my min heap, and after doing that I need to add my current element, right? So how I can do that, I just need to write min heap dot push curr or current. Okay, and after doing this, right, after coming out from this particular for loop, the kth minimum element will be present at the top of my min heap. Okay, so what I'll do, from here I can just simply return min heap dot top. Okay, so I hope it is clear to you. This is our code. It is pretty easy and simple to understand. So now let's analyze the time complexity and the space complexity for this particular solution. So here we are running a loop from I is equal to 0 up to k. So for this, the time complexity will be equal to O of k. And here we are pushing all the elements into our minimum heap, right? And you should know that the push operation takes a time complexity of log of n, where this n is nothing but the size of our minimum heap. Okay, so into our minimum heap, we are just storing k number of elements, right? So at max, my min heap can have k number of elements. Due to this, the size of my minimum heap will be equal to k. Okay, so that time complexity for push operation, you can say that it will be equal to log k. So from this particular for loop, I can say that the time complexity is equal to O of k into log k. Okay, now let's analyze the second for loop. Okay, so here you can clearly see that we are running a loop from k up to n. So you can say that for this particular loop, the time complexity can be equal to O of n minus k, correct? O of n minus k. And here what we are doing pop operation and push operation. Okay, so you can say that the time complexity for this particular operation can be equal to log of k, where this k is nothing but the size of our minimum heap, right? And you know that this if condition will not get executed every time we come into this particular for loop. Okay, but still in the worst case it can be. Okay, so let's say the overall time complexity for this particular for loop will be equal to O of n minus k into log of k. Okay, so the time complexity will be plus O of n minus k into log of k, and you can say that the approximate time complexity will be equal to n into log of k. Okay, n into log of k. And now if we talk about the space complexity, then it will be equal to O of k, right? Why equal to O of k? Because the size of our minimum heap will be at max equal to k, right? Now this is the most optimal approach for this particular problem, where time complexity is equal to O of n into log k, and the space complexity is equal to O of k. Okay, so I hope the code is clear to you, the approach is clear to you, all the three approaches which I explained you, I hope all of them are clear to you. So now let's fastly code this particular approach into LeetCode. So we are here on LeetCode. Let's fastly code the approach which we have just discussed. So what do we need? Firstly, we need a minimum heap. Okay, so this is the syntax through which you can create a minimum heap, and the name of this minimum heap is nothing but min heap. Okay, so what was our step number one? So our step number one was to put the k initial elements into our minimum heap. How I can do that? I can do that using a for loop. So here I can write int I is equal to 0, I is lesser than k, and I plus plus, and here I need to write min heap dot push nums of I. Okay, so I hope it is clear to you. From this particular for loop, what I have done, I have put it the k initial elements into my minimum heap. Okay, so now let's see what is our step number 2. So in step number 2, we have to traverse into our nums array from the kth index. Okay, so here I will write for int I equal to k while I is lesser than nums dot size, and here I need to write I plus plus. Okay, and now I need to get the current element. So the current element will be nothing but equal to nums of I, and I also need the minimum element. So the minimum element will be equal to min heap dot top. Okay, now I can simply compare them, that if my minimum element is lesser than my current element, if this is the case, then I need to remove the element with the minimum value, or you can say that I need to remove the minimum element from my min heap. How I can do that? I just simply need to write min heap dot pop, and then I need to put the current element into my min heap. So I can do that with min heap dot push current. Okay, so from this particular line I am putting the minimum from this particular line I am putting the current element into my min heap. Okay, I hope it is clear to you, and at the end I just need to return min heap dot top. Okay, so I hope the code is clear to you. Let me just run this. So here you can see that all the 2 sample test cases are running fine. Let me submit this. So here you can clearly see that this particular approach, this particular code is accepted. So I hope this video was helpful to you. If it was, then make sure that you like to this video and don't forget to drop a comment. And if you want this type of content regularly, then make sure that you subscribe to my channel, and we will meet again tomorrow with a new question.